Good morning, everyone. We're going to get started here. Welcome back to the third and final day of the First Nations Housing Conference. This presentation is on radon testing and mitigation. I'm pleased to welcome Rashid Suleiman. He's a regional radiation specialist for Health Canada in Ontario. And let's give him a round of applause and then we'll get started here.
Hello, everyone. Good morning. Thank you so much for coming to this presentation. I am so happy to be here. I'm honored to be here. Since yesterday, my colleague Heloise and I, we were at our Health Canada booth, and we got to meet a lot of the delegates here, and we had a lot of great conversations, learning about the important work that you do in housing and providing healthy homes for your communities. So I am honored to bring this presentation to you about radon gas. So thank you for coming. My name is Rashid, and I am the regional radiation specialist for Ontario. I'm actually new to this role. Before I was working with Health Canada, but in a more chemicals and pollutants aspect. You may have remembered me from last year. We gave a presentation on healthy homes and how to protect homes from chemicals and pollutants, which was very important, especially during COVID and more people spending time indoors. Since then, we've had a lot of great connections, and now I'm here to talk about radon specifically. Before I get started, I was wondering if anyone has tested their homes for radon. Okay, so a few, great. Has anyone actually ever done any mitigation work? Oh, and a few have even done some mitigation. So I'm guessing we might have a variety in the audience when it comes to radon knowledge and background. So because this is a planning session, I am really hoping to give a little bit of a radon 101 and talk about some ways you can bring testing and mitigation as an action plan to your communities. I'm actually very gracious also and thankful that some people from Indigenous Service Canada, who has also been doing a lot of great work with promoting radon and testing and mitigation, are also here. And if there's any questions that we have on the resources that you can bring, I will share some of the resources that I have brought. But if it extends beyond that, I hope to refer to you properly and have them also support you with resources. And a little bit about myself. I work in Toronto, which is on the traditional territory of the Mississaugas of the Credit, the Anishinaabe, Haudenosaunee, the Chippewa, and the Wendat peoples. I live there too. My family is from Guyana. Before I worked for Health Canada, I was in health and safety work with a cosmetic company. My background is in climate change, environmental sustainability. I also have a big background in poetry. I have a master's in fine arts and poetry because I think I like writing and have that as an output for change, actually, and climate change and social justice outcomes. Okay, I will get started. So first part, we are going to talk a little bit about radon, just so you have the background, what it is, how to test for it. And then we're going to go into mitigation. Not going to go into too much to mitigation because I could do a whole session on mitigation. Maybe next year we do a technical session and we go through all the different systems. But really, as a planning session, we want to show resources, the importance of testing, and how you can bring this to your communities. So Health Canada's National Radon Program was established in 2007 when Health Canada updated its codes based on the World Health Organization, its guidelines, from 800 becquerels to 200 becquerels. Becquerels per meters cube is how we measure the breakdown of radiation in the atmosphere. And so it was at 800, and then we lowered it to 200 and established the radon program, where we study radon, we do outreach and engagement, database and mapping, and a lot of technical aspects too, like working on the building code. So what is radon? Radon is a radioactive gas that is produced naturally by the breakdown of uranium in the ground. So being a gas, it wants to escape the earth. There's uranium everywhere. It's present in all soil across Canada. And as that soil breaks down, radon gas is released. Radon has no color, odor, or taste. So sometimes when we talk about radon, people are saying, okay, maybe they smell something in their home. or maybe something is making them feel sick. Probably that is not radon. Radon doesn't, you can't taste it, you can't smell it. All homes have some level of radon. The only way to know is to test. And as a positive note, all homes can be fixed. So just trying to picture our exposure to radiation compared to radon. Our lifetime exposure to radiation, all the ways natural or artificial, for example, cosmic rays, plants, the things we eat, radiation from the soil, and artificial ways like X-rays. Even carbon monoxide devices emit some level of radiation. It's very small. It only equates to about 0.01% of our lifetime radiation exposure. But radon actually represents almost 50% of a person's lifetime radiation exposure. So what is the health risk though? So radon is known as a carcinogen. It's actually a class 1, meaning there is substantial evidence for it to be known as a carcinogen. It is the #1 cause of lung cancer in Canada for non-smokers. It kills more than 3,000 people every year. So, and about 4,000 people are diagnosed with lung cancer related to radon every year. How does it cause lung cancer? Well, when we inhale radon gases, being a radioactive particle, it enters our lungs and it breaks down. And as it breaks down in our lungs, it releases a burst of energy, which gets absorbed by nearby lung cells. As those lung cells are now damaged from that burst of energy, as they reproduce, they can result in cancer cells. And so 3 things really matter when it comes to lung cancer and that health effects. It's how long we're exposed to it, to the radon, how much concentration of radon is in the air, and if we're a smoker. Because as you can see here, that people who smoke and are exposed to high levels of radon have a significantly increased risk of developing lung cancer. In fact, 1 in 20 non-smokers exposed to a lifetime of high radon will develop lung cancer. That's about 5%. But 1 in 3 smokers exposed to a lifetime of high radon will develop lung cancer. That's 30%. So it changes a lot. And lifetime, when we say lifetime, we're talking about 30 to 40 years. So as you can see, also radon is a long-term exposure. So it's not something that happens immediately. It's over a lifetime. So we at Health Canada do have sometimes a bit of a challenge with talking about radon and its importance about as a health issue. So trying to compare it with other deaths in Canada, for example. So radon, I said, kills about 3,200 people a year, but number of deaths by car accident, about 2,000, number of deaths from carbon monoxide, about 300, and number of deaths from a house fire is about 109. So in a home, you are required to test for carbon monoxide, have alarm. Same thing with a house fire, smoke alarms. So we just hope we would like that number, that 3,200 to go down simply by having people test for homes or starting to build those mitigation systems into the home. It still is a very difficult topic for us because to push these things over the years into the building code, because I think some of the challenge could be because of lung cancer itself isn't something people really worry about unless you're a smoker. Also, lung cancer doesn't really have any symptoms. Like how mold or smoke might have symptoms or asthma. Lung cancer is something that could get diagnosed later in life, and then unfortunately, the recovery rate of lung cancer because of when it's diagnosed is very, very low. I think it's 42% of people who have lung cancer recover, I think. So the risks of lung cancer from radon is significant, but preventable if we can learn how to build radon-resistant homes. And why are we focused on homes? Well, in partnership with Indigenous Services Canada, we have done a lot of testing in public buildings on and off reserve. From that research, we have actually learned that homes are where radon we're more concerned about radon because homes present the biggest risk for radon exposure. From our testing, we learned that radon levels in home represent about 5 times more than other buildings like workspaces, schools, daycares, and other types of public infrastructure. So we spend more time at home. It could be 70% of our time at home. So our major exposure to radon in our lifetime comes from our house, our home. So here is a map of some of the levels of radon in Canada. The darker areas represent where homes tested more than 10%. And then it gets lighter. What you can see from this map is mostly that no area of Canada is radon free. But there's a few things we also have learned from this map. That is, like, even if you live in an area with lower concentrations of radon, your house can be very different from somebody else's house, your neighbor's house. So you don't know what the level of your house is until you test. And I'll explain why they can be very different. So radon, this is how radon enters a house. Several factors influence the amount of radon that moves from the ground into the home. The amount of uranium in the ground. So we can go back to this map of Canada does help us understand that some areas do have naturally have higher levels of uranium in the earth. But it has to enter the home. So the amount of uranium in the ground surrounding your home is a factor. The construction type is a factor of how much radon can come into your home. If your home has a basement like this one we're seeing here, versus if it was on just a first floor, versus if it was on stilts, or maybe your home is built in a tree, you probably wouldn't have any radon if it was in a tree. But in a basement would probably have more entry points. It would be foundation conditions. So if you see the cracks in this foundation, causes an entry point for radon. So radon, being a gas, it just wants to find its easiest way to flow into the home and to escape. Once there's an entry point, it enters the home, and that's when it accumulates to high levels. When it's exiting from the soil just into the atmosphere, it gets diluted, and that is not a concern. Even though we're breathing it every day, not a concern. It's just when it enters the home and then accumulates to higher levels. Other factors are weather and temperature, winds, rainfall, pressure, all affect how much is coming through into the home. And it could fluctuate. And this is why actually we recommend long-term tests. So radon can fluctuate for all those reasons I was mentioning earlier. It could fluctuate over 24 hours. This is a graph of a 90-day test. And that's our minimum, 90 days for testing. And you can see because of those several factors, like even occupancy, lifestyle is a factor. So some people, if you're like my dad, wants to keep the windows open all the time. He doesn't feel drafts. Versus some people who keeps the windows closed. So they're trapped in with the indoor air more frequently. So you can see how it fluctuates over 90 days. So what we want to, because it's a long-term health risk, we want to know what average you are exposed to throughout your lifetime. So the best way to get that is to do a year-long test, but we say the minimum 3 months. And if you're going to do the minimum of 3 months, we hope that you do it during the colder weather, because that's when the heat is on and you're inside your home and you're more exposed to the indoor air. So you can see, again, it's going up and down. If you were to do a short-term test, you might get a false reading. You might get a false high, you might get a false low. And if you were actually to do a mitigation after, you wouldn't be able to compare it properly, because if you did a short-term test and then you did all that work to mitigate, and then you wouldn't know how effective your work is because you wouldn't be able to get a proper reading. So 90 days. Sometimes we get some questions about building materials and water, if radon is present in those. And yes, radon is present in water and building materials. However, building materials, it's not so much of an issue because one, building materials, it's a very low amount of radon that gets released from building materials. From granite, there is uranium trapped in granite. However, it's not porous, it's densely packed, so you won't have any radon actually even being released from the granite. From water, there is radon in water because groundwater, it passes through, but as it gets treated, radon gets removed through the treatment process. However, if you do have a well or water is not treated, radon is present. From our studies, we have learned that radon exposure is minimal that comes off of the water and not an issue. Also, drinking radon, not an issue. Its relation to cancer is only through breathing and when it interacts with your lungs. So how do you test? Again, short-term tests. If you came by our booth, you might have seen the short-term tests. We had some of those radon pucks. You can order them on takeactionradon.ca, and I'll discuss some resources and some strategies you can for implementing testing in the community. Or you can hire a professional. We do know that it may be hard to have access to professionals in certain areas. The certification program, CNRPP, who we fund, does have training programs, and I'll touch upon that a little bit later too. But our recommendation is the AlphaTrack because it is the most affordable way to go. If you are running a program, a testing in your community, you do want to try your best to support proper placement of those testing to your community members. We want it away from ventilation or fans, away from electrically powered appliances, away from heat sources, in an area where, ideally in an area where you spend at least 4 hours a day, so you know what you're breathing. We tell people if you don't go into the basement, there might be no reason to put it down there, unless you're going to plan to have people live down there, or you're going to use that space. So definitely want to support the placement. We have some examples here of where to place it on desks. However, from some communities, we do learn that sometimes if it's placed on a desk or an area, it does go missing. A dog eats it. I'm joking, a dog doesn't eat it, but it does go missing. So if whatever works for the community, if it's the basement, keep it down there because we just want to make sure it gets returned and doesn't go missing. The best strategy I've seen is people hanging it like in a little ornament or from the wall. So because it hangs down, it's in the breathing zone and it can't move anywhere. Nobody could accidentally move it or it drop and get swept away. So yeah, you definitely want to help do the placement. So just reiterating, we do encourage the long-term AlphaTrack, the 3-month one during the cooler season. Currently, there are no certified digital ones. I know there's a lot of people who like to see the numbers and the instant reading. That certification board is in the process of certifying digital monitors. They are a bit more expensive. They can range from like $100 to $200. They are going to be certifying them, but at the moment we have the AlphaTrackers, and those are the ones that we have in our programs where we have like free distribution. So 200 becquerels is the guideline and just proper placement. Okay. What to do now if you do have high levels? Well, you'd want to reduce within 2 years. So the thing about radon, because it's a long-term health effect, it doesn't need immediate attention unless it's above 600. That's where we would recommend immediate attention at very high levels. Okay, so that's radon. I hope you got to learn a little bit about radon today, and I want to now talk a little bit about the mitigation. And before I get into the mitigation and the building code, there's this really interesting study we did about the implementation in Nova Scotia on the level 1 of the National Building Code, because this is an area that does have high level of radon. So they implemented in 2010 National Building Code, 2011, where you had to have the soil gas barrier and the rough-in pipe installed. And we gave everybody these AlphaTrackers. We tested all their homes, their occupancy lifestyle, the size of home. We looked at all these things to find out did the soil gas barrier and rough-in pipe help with this high radon, Halifax being a high radon area? And I'm going to ask you why you think these numbers exist, because just going through it, what we found, if you can see, so they installed this vapor barrier or the soil gas barrier in a rough-in, which is a mitigation system, but not completed. It's just partial to be completed later. And they found that of the older homes, the homes that didn't have that, the soil gas barrier or the rough-in, 44% tested under 200 and 33% of the newer homes tested under 200. But if we kind of go down, so 200 to 600, they're pretty much the same. The older homes tested pretty much the same. And over 600, the newer homes, 27% of the newer homes tested over 600. And 14, even though they had the soil gas barrier and a rough-in. So I don't know, what comes to mind to you? Why do you think the newer homes are testing for higher levels of radon? Anyone have any ideas? That's one of the major reasons, yes. Also, we found that, or we speculate that the gas barrier is not being installed properly, or there's too many rooms for failure. So you're installing it on like a gravel, and if it gets punctured during that installation, it just needs one hole for that radon gas to enter. And with an more energy efficient house, you're trapped in with that air. Also, the point of the rough-in is that you're supposed to follow up with a test afterwards. Test, if it has high levels, you just simply complete that pipe, but nobody tested. So that's why all these homes, 20% of homes had such high levels over 600, because nobody actually completed the pipe and did the testing. So exactly it, just going on energy retrofits and energy efficiency from our studies, from mostly taken from the US studies who are really going into this, they've found that as we build more energy efficient houses, building houses to use lesser energy essentially, we're finding that there are a lot of impacts on the indoor air quality within those houses. Actually, for radon specifically, as we build more energy efficient houses in the US, they're seeing radon levels just rise by 22%. So you can imagine that for all other types of pollutants that might be in the home as well. For it to run effectively, you have to like be running that HRV all the time in those energy efficient homes and stuff. Okay, so now let's quickly, because it's a short presentation, I'll try to cover some of this, the energy, like the retrofits, sorry, the mitigation systems, but I just want to show you also what the National Building Code is saying. That's what we implemented in Nova Scotia. It's the soil gas barrier and the rough-in, and that's what we're hoping people to do, and it's effective as long as the rough-in is completed into a system. However, so that's an example of the rough-in. So you can see the soil gas barrier, you can see the membrane sealed with a flexible sealant, let's say like polyurethane, oh, I can't pronounce it right now, but a flexible sealant, because during the curing process, we do find that over the first 2 years, there are changes, and that if it's not sealed properly, that seal can also become undone. You'll see we do want it for it to be most effective, and the pressure to change the pressure differentials, and for it, you want it in the center of a home. If it's about 1,500 square feet, if it's larger, you have a bungalow and you want it to be, or maybe you want it to run closer to the wall, you would then want the pipe to be extended into the center of the home. And that's, so you have the earth, you have that a granule permeable gas layer where that pipe is running, you have the membrane, the soil gas barrier, and then you have your concrete floor slab. Okay, so Ontario, just as an example, all provinces has interpreted or taken upon themselves to have different building codes. I just want to give you an example of how Ontario has implemented the National Building Code. They actually had made it a either or thing. You can either have the soil gas barrier or a rough-in for future depressurization. So because of that, we started coming up with standards. Standards are just supplementary work that we hope that people can, it's like a recommendation or a standard that somebody can take upon. And so we are also working right now very, very quickly to try to get some of these standards implemented into the National Building Code. So there's 3 levels of measures. It's either level 1, soil gas barrier, so you have to have both, radon, rough, and pipe. Level 2, so all new construction you have to have the passive vertical stack, or new construction must have the active soil depressurization system. And I'm going to go through what each of those look like really quick. So the level 1 rough-in for active soil depressurization provides minimum protection and provides provisions for a radon rough-in stub, as well as provisions for sealing soil gas entry points. Level 1 is not a complete reduction system, but it allows for easier conversion to one in the future. So you'll see, as I was saying, you have that granule drainage layer. It's a continuous layer of coarse granule material that's poured on top of the exposed soil. You have the seal membrane, and the seal, somebody was asking me at the booth what it could be sealed with. It could also be sealed with, it doesn't have to be caulking. It could just be fabric, metal. It just has to provide a layer so no gas comes through. A cap, the cap is very important because you want it to be noticeable. You want it to be labeled radon. You don't want, in the past, we've seen people write radon pipe instead of sealing it properly. And sometimes those pipes turn into plumbing by mistake in the future. And a suction point. So here it is in a blueprint. If you prefer that, you can see the void, that suction area, the void space for suction. This person ran it so it's closer to the wall. So they had to run a pipe across into the center of the slab. Sometimes in larger spaces, they also make perforated pipes to run in different areas to capture more areas of the soil. And just to note where it's coming out, there are clearances from windows or other houses. Those clearances, though, are, I think it's 2 meters, but they are just precautionary from our studies. As soon as the radon exits that pipe, it gets diluted into air pretty instantly. So, but we still have precautionary clearances from like a window that you might open because we don't want it to come back in. So this isn't a complete system yet. Again, if you are going to do this, you have to follow up with the testing and to find out if you need to install that radon active pipe. So level 2 is a passive vertical stack. It provides moderate protection and includes all provisions of level 1, with the addition of extending the pipe stub to create a full vertical passive without a fan. Radon stack system that runs upwards through the inside of the building envelope and vents above the roof. So it is a passive. So it is using a chimney effect. As hot air rises, it is pulling radon depressurization naturally and having it exit. We find it about 40 to 90%. Realistically, I think it's about 50% effective. So if you are, I'm not saying it's not something that it's worth trying, but if you're in an area where your homes are testing at like 800, if it's 50% is what I'm seeing in pictures, it's only going to reduce it to 400. So that one of the things that we recommend with this too, if you see that little black part, insulated section of stack, sometimes we recommend is if you're able to put an outlet up there for a fan to turn it into an active stack in areas that are that need it, because they have these systems kind of need a few things to work effectively. First, it needs like the climate has to be perfect. So in the US, in some areas where it's very hot and you have the air conditioning running all the time and it's colder, it doesn't work there because it needs heat. Cold air pushes down. In our areas with the heat, it's warmer inside, so the heat will rise. It does work a little bit more effectively. There has to be no punctures in that membrane. If there's any, the pipe is 3 to 4 inches. If there are more punctures that exceed that pipe, it's not going to start pulling up naturally. The gas is going to escape through the membrane. What else? It has to be vertical because of climate. And so if there's any horizontal bends, it'll lose its efficiency. Okay, and now level 3. Level 3 is the full active stack. So what we have here, this is the most effective. This reduces radon up more than 90%. So full active soil depressurization system provides maximum protection and includes all provisions from level 1 and 2 with the addition of a radon fan to create an active soil depressurization system. It is a complete radon reduction system for all active soil depressurization systems. A fan draws air up the vent stack to depressurize the grass permeable layer beneath the home. It's pretty energy efficient. The newer fans are very quiet. I've even heard that the fan also helps with moisture levels in the home too, as it's, that's what I've heard from radon professionals. So that's it there, venting out to the side of the house. And that's what you would be, if you had the rough-in, you would want to complete the system that way, a sidewall discharge. Okay, so I want to get, with the last 10 minutes, I want to get into, now that we were able to learn a little bit about the systems that are in place, we know a little bit more about radon and why it's important to bring that information to communities. I want to talk about the resources. We touched base with First Nations National Building Officers Association, and they asked me to share their resources to you. So I'm just going to read from their slides. So many of Indigenous communities located on Turtle Island may have radon gas issues. Building homes with less radon reduces lung cancer risk and saves lives within the community. Important standards have been developed to build radon resistance home to help Indigenous communities. Always assume that you have radon and mitigate it. So when you are planning homes, assume that you have radon. Before construction, to mitigate radon gas, it is estimated to implement before construction 800 to 1,000. However, after construction, to mitigate radon gas, it is estimated to be approximately 5,000 to 7,000. And I think we'll talk about some of the Indigenous Service Canada fundings, but I think it goes for mitigation systems up to 5,000. They have some important documents to review to support you. It's the Radon Resistance Home in Indigenous Communities, which is a free document that you can access. They also have webinars, and which is really wonderful, if you are implementing new blueprints or want some architectural advice, they provide that service, a free service. You can just contact them at info@fnnboa.ca, and they can review your plans for radon mitigation. They also note that chief and council are the authority having jurisdiction and must ensure homes are built to building code, including addressing radon gas. Must build safe homes for their members. So, and before I get to common questions, another resource I want to provide, you can always contact us. Sorry, I don't have my direct email up there, but I have our generic email. There is a Take Action on Radon program, and November is National Radon Month, and they run a sweepstakes, 100 test kit challenge, and they also do some mitigation support. The 100 test kit challenge is something that's pretty amazing. They have worked with many First Nations communities to implement testing. So you would apply for their request the 100 test kit challenge through takeactiononradon.ca, and they would provide 100 test kits to distribute in the community. They would even come to the community if needing a presentation or any talk about how to implement the program. You test the community, all the results come back, and then they would also help you establish a mitigation plan too. So that's Take Action on Radon. And I'm not familiar with Indigenous Services Canada and support on where it. I know they've been doing a lot of work. It's just a little bit new, and they have this infrastructure group. I do have our colleague Siva here that maybe can answer any of the questions about Indigenous Services Canada funding. I don't know if you want to say anything about any of the funding.
Yeah, just briefly, last year we looked into Radon and we got a number of reports from environmental health officers who work with their communities, and we got some advice from them to get started working on it. So last year, in communities where we did new construction approvals, we indicated in the letter that if you decide to do radon mitigation for new construction, we could cover an additional cost of up to $5,000 per home. So, you know, you have some mapping and some readings and information out there. If you feel that your First Nation is located on a land where the concentration might be high, you can apply for an additional subsidy to do the mitigation from the vehicle.
That's wonderful. So that concludes the presentation. You're free to contact me if you have any support, or even we do work with communities to do awareness programs too, or to help with testing, provide pamphlets. And yeah, if you have any questions, I'll be here. You can ask any questions. We'll pass the mic around. Nope.
Subsidy? Through Indigenous Services Canada. So it would be part of your new construction application or your renovation application. Because it has an impact on health, it falls under health and safety renovation.
For existing homes where they find it has it, does Indigenous Services Canada also have a program?
Yeah, it would be part of the regular renovation program and fall under health and safety renovation.
Yeah, how much is it? Is it also?
It's not specific to radon. It could be any health and safety items within your home. So you just have to. No, well, there is a cap on overall health and safety renovation depending on where your service is located. Zone 1 is around 48,000. Zone 4 is around 68,000. And the rest would be on the other two.
Great, thank you, Siva. Hey. That's it. So thank you everybody for having me. It was a pleasure.